In this video, we'll be looking at some of the situations that occur when solving linear systems of equations. The system on the screen is a 3x3 system, so 3 equations and 3 variables, x, y, and z. And if we put it into a matrix in our calculator, as I've done here on the left, we can solve for this using the RREF function. So let's go ahead and do that. So we'll go to second and then matrix, over to math, and down to RREF, as we did in an earlier video. And so we're going to select matrix A. And what we see is that there is a row of zeros across the bottom. Anytime that happens, what that tells us is that there are an infinite number of solutions to this system. So what we want to do is we want to write out the equations from the simplified matrix. So that top row, 1, 0, 3, 2, that's 1x, or just x, plus 0y, plus 3z equals 2. The second equation is 0x plus 1y minus 13z equals negative 1. And so what we're going to do is we're going to solve for x and y in terms of z. So what we'll do is we'll take this top equation and we'll subtract 3z from both sides. And so what that gives us is x equals 2 minus 3z. The second equation will add 13z to both sides. And that's going to give us y equals negative 1 plus 13z. And so the solution to this we'll put as an ordered triple, just as we would if we had ended up with 3 numbers, one for x, one for y, one for z, where the first entry is x, 2 minus 3z. The second entry is y, negative 1 plus 13z. And the last entry is z, which is just z. And so that's how we would write the solution to this system of linear equations, which has an infinite number of solutions. And so what this means is that we can choose any number we want for z, plug that in for each, and we would have a new solution. Let's look at another example. This example I also have in the calculator as matrix B. This is also a 3x3 system, and so we can solve it the same way. So we'll go to second matrix, over to math, down to RREF, and then we'll select matrix B. And we end up with some decimals, so we'll use the math button and select the first option there, fraction, to clean it up a little bit. Now what we see on this one, we don't see that row of zeros across the bottom. Now what we see across the bottom is 0, 0, 0, 1. And so what that says is 0x plus 0y plus 0z, which is just 0, equals 1. And we, of course, know that that's impossible. So this system has no solutions.